For topic three, we're going to compare fractions, and I just want to do a quick reminder. When you're comparing numbers, you use inequality symbols. So you saw these in the previous chapter. So we have less than, and we have a greater than. And remember, if it kind of looks like a squished capital L, that's the one that stands for L for less than. And you always want the point to go towards the smaller number and the wider part of the inequality symbol to go towards the larger number. Now, when it comes to comparing integers, we compare those kind of thinking of a number line. With fractions, it's a little bit different, okay? When it comes to fractions, to compare fractions, you can compare the numerators as long as you have the same denominator. So if the denominators are the same, we just compare numerators. We just compare numerators. And so if we're dealing with two fractions that are unlike in the sense that they do not have common denominators, we need to first find an LCD, then find equivalent forms of each fraction using the LCD, and then we can compare the numerators, okay? So if the denominators are the same, just go ahead and compare your numerators. Whichever one has the bigger or smaller numerator is the bigger or smaller fraction. Without common denominators, we have to do a little work, okay? So again, step one, find the LCD. Step two, find equivalent forms of each fraction using the LCD, then we compare the numerators, okay? So luckily, nothing here is really that new. We already know how to find LCDs and equivalent forms of fractions, okay? So for example 3, it says insert a less than or greater than symbol to make each statement true. All right, so first up we have 5/8 compared to 11/20. So let's find an LCD. And in this case, let's just practice doing the listing out multiples because this one won't be too bad. So remember, you can list out multiples of your denominators until you find a multiple that they have in common. So 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, and 8 times 5 is 40. And I'm going to stop there because I kind of know that this is going to be a special number here. So now 20 times 1 is 20, and then 20 times 2 is 40. So we can see right here that the LCD is 40, okay? So now I want to find equivalent forms of each of the two fractions, and then we're going to compare the numerators of the new equivalent fractions. So I'm going to do this kind of off to the right. So we had 5/8. We want to rewrite 5/8 as something over 40. So we ask ourselves, what would we multiply 8 by to get 40? And the answer would be 5. So I want to, I hope somebody caught that mistake. I have 8. I need 5/8, not 5 over 80. So that should be an 8 right there. I don't know why I put the 80. So what we would have to multiply 8 by to get 40 would be 5. So I want to multiply top and bottom by 5. That's my weird form of 1. So I end up getting 25/40ths. That's the equivalent form of 5/8. So 25/40ths. Now I want to do the same thing for 11/20ths. I want to rewrite this as something over 40. So what would I have to multiply 20 by to get 40? Well, I would have to multiply it by 2. So I want to multiply top and bottom by 2. That's my weird form of 1. So 11 times 2 is 22. So I'm comparing 25 over 40 to 22 over 40. And since 25 is greater than 22, that tells me that 25/40ths is more than 22/40ths, which ultimately tells me that 5/8 is greater than 11/20. Okay, so it's a little bit of work. Again, we have to find the LCD, the equivalent forms, then we just compare the numerators, and that tells us which fraction is bigger. All right, for part B, what's going to make part B a tiny bit more complicated is we're dealing with two negative fractions, and generally speaking, it's a little bit harder to compare negatives than it is to compare positives. Nothing terribly difficult, it's just a little bit harder. So let's find our LCD. In this case, I notice my LCD or my LCDs. I notice my denominators are 20 and 5. 5 happens to be a factor of 20. So if I were to start listing out multiples of 5, I would say, okay, well, 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, and 5 times 4 is 20. Well, I notice that 20 is the denominator for the other fraction. So by default, 20 is the LCD here. Okay, so if one of your denominators automatically divides into the other, the bigger denominator is the LCD. So that's the case here. So we have our LCD. Now let's get our equivalent forms. So I don't need to rewrite negative 17 twentieths. It's already got the LCD as the denominator, but I do need to rewrite negative 4 fifths. So I want to rewrite negative 4 fifths as something over 20. So I asked myself, what would I multiply the denominator of 5 by to get 20? Well, I would multiply by 4. So I want to multiply the top and bottom by 4. That's my form of 1 that I'm looking for. And negative 4 times 4 is negative 16. So what we're really comparing is negative 20 to negative 16 twentieths. I think I said we're comparing negative 20. I should say we're comparing negative 17 twentieths to negative 16 twentieths, which really means we're comparing negative 17 to negative 16. And if you can envision a number line, this is negative 16 and this is negative 17. So when you're dealing with the negative side of a number line, the further away from zero, the smaller the number is. The closer to zero, the larger the number is. So negative 16 is closer to zero. So that tells me that negative 16 is bigger than negative 17. So since negative 17 is less than negative 16, negative 17 twentieths is less than negative 16 twentieths, which ultimately tells me that negative 17 twentieths is less than negative 4 fifths. Okay, so it's a bit of a process. Again, you find your LCD, you find your equivalent forms, and then you just compare numerators. Okay.